Hello everyone and welcome to St. Andrews Institute of Technology and Management. St. Andrews Institute of Technology and Management is the best college in Delhi NCR in northern India and entire India. This is the best college that you can choose for your children or for yourself. We offer the best in education and provide the best placement. The subject that I'm taking in this video is Principles of Software Engineering, CSE 302F. This is a CSE 6 semester subject in accordance with MDU University Rohtak. The topic discussed here shall be the requirement analysis and specification, that is requirement engineering, system modeling and simulation, analysis principle modeling, and partitioning software. I, Shalini, from CSE department shall take you forward. Requirement analysis and specification. Requirement analysis, also called requirement engineering, is the process of determining user expectations for a new or modified product. Requirement engineering refers to the process of defining, documenting and maintaining requirements in the engineering design process. That is, we define the requirement also, we document and we maintain the requirement also. So requirement engineering provides the appropriate mechanism to understand what the customer desires, analyzes the need, and then assess the feasibility. It negotiates a reasonable solution, specifying it clearly, validates the specification, and manages the requirement as they are transformed into a working system. Okay, so from analyzing the need to a working system, how they transform is this entire processes of requirement engineering. Requirement engineering is the disciplined application of proven principles, methods, tools, and notations to describe a proposed system's intended behavior and its associated constraints. So it's a four-step process which include feasibility study, requirement elicitation and analysis, software requirement specification, software requirement validation, and at the end, management. Okay. Feasibility study, requirement elicitation and analysis, requirement specification, and requirement validation. So the output of feasibility study is the feasibility report. Output of requirement elicitations and analysis is systems model. From specification we get user and system requirements, and from validation we again get requirements, and all these are actually being documented, right? And all this is software engineering engineering management, like requirements engineering management. So feasibility study, the objective behind the feasibility study is to create the reasons for developing the software that is acceptable to users, flexible to change, and conformable to established standards. Types of feasibility: technical feasibility, operational, and economic feasibility. Technical feasibility evaluates the current technologies which are needed to accomplish customer requirements within the time and budget. Operational feasibility assesses the range in which the required software performs a series of levels to solve business problems and customer requirements. Economic feasibility. Economic feasibility decides whether the necessary software can generate financial profits for the organization or not, right? So technical deals with the if it is in synchronization with the current technologies and it's in time and budget. Operational, it will have a feasibility range as to what are the series of level to solve this business problem and customer requirement. And economic will deal with the financial parts, right? Next we come to requirement elicitation and analysis. This is also known as the gathering of requirements. Here, requirements are identified with the help of customers and existing system processes if available. Analysis of requirements start with requirement elicitation. The requirements are analyzed to identify inconsistencies, defects, omission, etc. We describe requirement in terms of relationship and also resolve conflicts if any. What are the problems will be faced with this? getting all and only the right people involved. Stakeholders often don't know what they want. Stakeholders express requirement in their terms. Stakeholders may have conflicting requirements, right? If there are a number of them, so they might have conflicting, and even one does not know his own requirements also, so what exactly he wants, right? So requirement change during the analysis process. Organizational and political factors also, like they also influence your system requirements, because there are lots of politics that goes into the into the an organization, so that also affects this process, and it's a I would say a hurdle. Okay, so how you do this? There's a domain, and you understand the domain, then you try to collect requirements, then you try to validate them, and then again it enhances the validation, enhances your understanding of the domain, right? Then you classify your requirements, you resolve if any conflicts are there, you prioritize them, and then you define and with specifications, right? So software requirement specification, or SRS. Software requirement specification is a kind of document which is created by a software analyst and the requirements collected from the various sources. It is the job of the analyst to write the requirement in technical language so that they can understood and beneficial by the development team, right? So the analyst has to write the requirement in a language that is beneficial to the development team, because ultimately they are the one who are developing the software, na? They are the one who are coding, so it has to be the analyst has to write in a proper way, right? And this document is very very important. The way there are different models at this stage include your diagrams, that is entity relation, your DFDs, data flow diagram, functional dependency diagrams, data dictionaries, etc. So these are the ones that are used in this. So data flow diagrams, what are they? They are widely used for modeling the requirements. It shows the flow of data through a system, like how your data is flowing, how it is passing from one step to the next. The system may be company, it may be organization, or any procedure, right? So a computer hardware or software system, or any combination. It is also known as bubble chart or data flow graph. Data dictionaries. Data dictionaries are simple repositories that are used to store information about all data items defined in DFD. So any kind of data that is being defined in DFD, so that will be simply stored into the data dictionary, right? So at the requirement stage, the data dictionary should at least define customer data items to ensure that the customer and developers use the same definition and terminologies, right? So this dictionary will actually act as a standard, or you can say a guideline, right? So whatever that you are using into the system, whatever the term you're using, whatever the data you're using, everything will be defined in the data dictionary. Okay. Next is entity relationship diagrams. Another tool for requirement specification is the entity relationship diagram, often known as diagram. It is a detailed logical representation of the data for the organization, and it uses three main constructs, that is data entities, relationship, and their associated attribute. So what are the data entities? They are the primary ones, and the relationship that they share in between them. And what are the attributes? See, everything has an attribute. So anything you define, every entity has to have will be having some characteristics of its own, right? So all these data entities will actually have their own characteristics, and then there will exist some relationship between them. So this is what is defined by a diagram. Next we come to software requirement validation. After requirement specifications are developed, the requirements discussed in this document are validated. The user might demand illegal, impossible solutions, or experts may misinterpret the needs, right? So you always need to validate it, so they can be checked upon the following condition if they are can practically implement. So that is also possible now, that you have to first see that you have to practically implement. I cannot also design a software for me that I should press the button and within 1 second it should take me from here to moon. So how will that happens? Like from 1 second, it's like you have to say you're bounded by gravity and time. So you have time domain and space domain also. So that is you have to first see if it is practically implementable, right? Or I can say I should press a button and then I should know what you're thinking. So this is entirely, this has to be looked in, right? So your this this has to be done, that yeah, if is your possible, is this your practically implemented project or not that you're taking in, if they are correct and as per the functionality and speciality of the software, if there are any ambiguities in them, right, if they are full, and if they can describe, like they are easily describable. What are the techniques that are being used? So the first is requirement reviews inspection, that is systematic manual analysis of the requirement, right? Prototype is you make a model, a small model with the I would say with the existing requirement, and then again the small model will help you refine your requirements, right? Test case generation, developing test for requirements to check testability. Automated consistency analysis, that's checking for the consistency of structure requirements descriptions. Next we come to system modeling and simulation. See, system modeling is the process of developing abstract models of a system, with model presenting a different view or perspective of that system, right? So system model, it represents aspect of a system and its environment. System modeling is a mean of representing a world view, that is a detailed view of the system. So you get an overview of the system. What are the features of it? Define the processes that serve the needs of the view under consideration. Represent the behavior of the processes and the assumption on which the behavior is based. Explicitly define both an exogenous and endogenous input to the model. Represent all linkages that will enable engineer to better understand the view. So to construct a model, the engineer should consider number of restraining factors like assumption, simplification, limitation, constraint, and preferences. So these are all supposed to be kept in mind while designing the system. Assumptions: in this input domain, the system engineer makes certain assumptions about the range of allowable human movements. That what will be the range that your system will operate into, right? So that range of input and processing can be limited. Simplification: this enables the model to be created in a timely manner. So simple will always, simplified process will always help you in saving your time. Limitation, like what are the bound of your system. Constraint, so they will guide the manner in which the model is created and the approach taken when the model is implemented. So it will have some constraints and limitation. You need to keep that in mind. And preferences, that is what is the preferred architecture of all the data function and technology. That is, if you have some preferences that okay, that this will be the kind of this will be the kind of framework, or this will be the kind of architecture that we have planned in for there, right? Next we come to system simulation. See, simulation means you imitate the operation of real world into a system, right? We earlier used to play video games, or VR, virtual reality is all simulation. So system simulation is what is a set of technique that uses computers to imitate the operations of the various real world tasks or processes through simulation, right? So it imitates them, it imitates the operations of various real world tasks, right? And in what context it is used: simulation of technology, safety engineering, for testing, training, education, video games, scientific modeling, human system modeling, clinical healthcare simulators, right? So all this is being used in here. And this clinical health simulators, I think these are the most widely researched topic also, right? So these tools enable a system engineer, it actually help you take a test drive of the specification of the system, so you can always better it. Next we come to analysis principles modeling. Analysis modeling is a technical representation of the system. It acts as a link between system description and design model. In analysis modeling, information, behavior, and functions of the system is defined and translated into the architecture, component, and interface level designing in the designing module. Right, so it's a link between your system description and design model. So your analysis help in linking the two, the description to the model, and all the behavior and functions, they are very well understood in this analysis part. So what's the objective of this analysis modeling? it must establish a way of creation of software. How do you are actually establishing this software design? And you must just describe your requirements to the customer, right? And it must define a set of requirements which can be validated upon the software is built, like once you build it. So it need to have a proper setup. So analysis is very very kind of important thing. See, right, you have a data dictionary in the middle, then you have ER diagram, data flow diagram, strain transition diagrams. The ER ones has a data object description, and DFDs have a process specification, and the state transition tells you the control specification. So all this is being done into this analysis, so you properly map onto it, right? You properly see how they are working, you analyze it in detail in this. So data dictionary, ER and DFD diagram we have discussed in this software re-engineering also. State transition is something new. See, in state transition, it shows various modes of behavior, that is states of the system, right? So what are the different modes of the system? What are the different state the system is in, right? And how it transits from one to other. So how it is doing this, right? Process specification. It stores the description of each functions present in the data flow diagrams. Control specification. It stores the additional information about the control aspects of the software. Data object description. It stores and provides the complete knowledge about a data object present and used in the software. So now what stores what the process specification as the name specifies. It will has all the functions. The control will look after the control aspect, and the data will contain all the data or the complete knowledge, right? Next we come to partitioning software. See, problem is partition that into parts like that can be easily understood, and you can easily establish an interface between the part. So it should be, and it is very very important, like, because why? You have to complete the project on time, and there are multiple people working on it. So you make it as such that they can be developed individually, and then there is a proper interface mechanism has to be developed. Is how do you interface all of them? Partitioning decomposes a problem into its constituent parts. Conceptually, we establish a hierarchical representation of function or information and then partition the uppermost element by exposing and functionally. So, exposing it increases detail by moving vertically in the hierarchy, and functionally decomposing the problem by moving horizontally in the hierarchy. So, you expose and then you do the functional requirements also. See, if I have a same home security system, that I can look that the homeowners need to configure the security measures installed. So first is you buy them and then you configure them. Then you see all your sensors are attached and connected to the system. And then you interact with the homeowner through a keypad and function keys. So how that safe home security system will interact with, will it use keypad, will it use functions key, is it dynamic, is it static, right? So you will make various you partition it into different things. The installation part will be different, the monitoring part will be different, and the interaction part will be different. Suppose if I take if I take this home security, so it will again be partitioned into three: installation, monitoring, and then this interaction part. So then in monitoring I will see that how is it doing, like how, what are my sensors that are involved, where are they supposed to be put up. All this has to be it further and further partitions, and then you interface all this, right? Some important questions are, what is requirement engineering? And this is the first question is very very important. Requirement engineering is, I mean, like, it's being asked again and again. And what are the various steps? So you need to just bring this answer to this. What is system modeling? So you write a short note on system simulation. The two can be together, or that they can be asked into small questions individually. Then you write a short note on analysis principles modeling, and last is, what do you understand by partitioning software, right? So that's all for today. Thank you so much. Have a great day.